Hello, my chemistry learners, my students all over the world interested in knowing chemistry. Okay, wherever you are watching this video, I send you greetings to you. This is order of reaction. Okay, I'm a chemistry tutor, Mr. Honesty Akpeji. Now, this is order of reaction. Let me quickly explain what it is all about. I want to assure you at the end of this video, you will be gladly you did watch it, okay? What is order of reaction? Order of reaction is the power to which the concentration is raised, okay, for a particular species in rate law, okay? When you write your rate law or your rate equation for a particular reaction, you can determine your order of reaction. Understand that the rate law is determined from the experimental point of view. Okay, the rate law of a reaction is determined experimentally and cannot in general be inferred to chemical equation for that reaction. Okay, please note that, and it is very important you understand that. Okay, so for order of reaction, okay, if you have a reaction A to give you P, okay, so how do you write the rate law? Yes, the rate law. I have done a video on rate law and rate equation. So you go to that video, rate law, rate equation, okay, and you will understand how to write rate law or rate equation. So from rate equation, R is equal to, you introduce your rate constant, then the concentration of A raised to the power of 1. Why 1? Because that is the coefficient, okay, of this reactant. Okay, so after you have written your rate law, the power to which the concentration of this reactant is raised, that power is called the order of reaction. So order of reaction here is 1. So this reaction is referred to as a first order reaction. Okay, so here the reaction is a first order reaction. There are other reactions. If you have, I'm using lettering to explain this. Okay, if you have a reaction like A plus B to give you 6C, okay, plus D. How do you write the order of reaction here? Order of reaction with respect to A, order of reaction with respect to B. So with respect to A, our order of reaction, okay, you write the rate law, which is Ka, concentration of A raised to the power of A. Okay, this is the rate law with respect to reactant A. Then with respect to reactant B, R is equal to Kb raised to the power of B. So you can combine these together to give you a single rate law. R is equal to the same R, the same K, is A raised to the power of A, then B raised to the power of B. So this is the rate law for this reaction. Okay, so with respect to A, it is eighth order reaction. Now you call this eighth order. Okay, with respect to B, it is bth order of reaction. B can be any value. Okay, so the overall order is the sum of the total. Okay, the sum total you have. So overall order, okay, overall order will be equal to A plus B. I hope you understand that. So that is how you determine the order of reaction. Of course, we have a first order reaction. Types of order of reaction, we have zero order reaction, we have first order reaction, we have second order reaction, we have third order reaction. Okay, and depending on what you have, you can have a fourth order as the case may be. Okay, so the first order reaction is such that the product depends on the concentration of the reactant. As you can see here, this is a first order reaction because the product depends on the concentration of the reactant. Okay, the power to which the concentration is raised is 1. Okay, because of that, it is a first order reaction. So from what you have here, you can see that the product actually depends on the concentration of only one reactant. Okay. So I believe you do understand that if you have a reaction that is 2A to give you P, okay, where you have this is the reactant, if you write your rate law, we give you Ka raised to the power of 2, okay, that means in this case, the power to which the concentration of this reactant is raised is 2. Therefore, order of reaction is equal to 2. I hope you understand that if you have reactant to be a plus B to give you a product P. So how do you get your order? Your order of reaction will be K to the reactant A, then reactant B. So the order of reaction here is 1. The order of reaction here is 1. So the overall order for this reaction will be 1 plus 1, which is equal to. So you can say this is a second order reaction. This is a second order reaction. Okay, if you have a reaction A plus 2B to give you a product P. So your rate law will be R is equal to K concentration of A, then concentration of B raised to power 2. So you can see, you can determine your order of reaction here. The order of reaction here is 1, the order of reaction here is 2. So the overall order is equal to 1 plus 2, which is equal to 3. So with respect to A, the order of reaction is 1. With respect to B, the order reaction is second order. So, but the overall order is 1 plus 2, which is 3. So, this reaction is a third order reaction. Okay. So, we have different types like that. We have first order, second order, and third order. But most importantly, first order reaction and second order reaction are mostly very, very popular and useful in every reaction. Okay, so look at this reaction where you have 2NO plus hydrogen, okay, to give you N2 plus 2H2O. Okay, by chemical point of view, from the chemical equation point of view, the order of reaction is what now? KNO raised to power 2, you will write the rate law. Okay, then H2 raised to the power of 2. So this is a fourth order reaction from the rate law that we have written, except it is experimentally determined. Understand that rate law are always determined experimentally. Okay, it is determined experimentally, okay, rather than the chemical point of view, chemical equation point of view. So experimentally determined from the concentration of reactants and the initial reaction rate, we can determine the reaction order or the order of reaction, and then the rate constant of the reaction. What I mean is, from what we are doing here, we can determine the rate constant, we can determine the reaction rate, or we determine the concentration of the reactant depending on how the question is said. Also understand that reaction order is always defined in terms of the reactant, not the product concentration. So you define the order of reaction in terms of the concentration of the reactant, not in terms of the concentration of the product. Okay, I hope you understand that. So that is why we said order of reaction is the power to which the concentration of the reactant is raised, not the product. Also understand that the order of reactant is not related to the stoichiometric coefficient of the reactant in the overall balanced equation. Okay, when you have a balanced chemical equation, okay, that the order of reaction does not relate to the stoichiometric coefficient of the reactant. It does not actually relate to the stoichiometric coefficient of the reactant. Understand? Because it is experimentally determined. Okay, so from the experimental point of view, whatever the rate law gives you is the rate law. So when you are given a question to solve, and the question they have, or if they have specified that it is a first order reaction, but from what you are seeing in the equation, you are seeing a second order, please take the question as a first order so that you could get the right answer, because that is the experimental view of the equation, not the balanced chemical, the one you balanced, and then you now alter the order of reaction. I hope you understand what I am saying. Okay. So we also have reaction that are zero order. If you have A to give you P and you write your rate law gives you, from the experimental point of view, you have rate law to be like this. That means this is a zero order. What can we deduce from these three things? This is a first order, this is a second order, this is a zero order. Okay, and meanwhile this is a third order. Okay, what do we deduce from these three things? I've given you 3 points before. First point is that rate law are always determined experimentally. Please understand that. Okay, and from there you can determine the concentration of the reactant, you can determine the initial reaction rate, you can determine, other things like the rate constant. And also understand that reaction order, the order of reaction rather, is always defined in terms of the concentration of the reactant and not the concentration of the product. Also understand that the order of a reactant is not related to the stoichiometric coefficient of the reactant in the overall balanced equation. Okay, that I have explained. Now you can see what I will deduce from here, that this is a first order reaction because the product depends on only one concentration. Okay, or because the power to which the concentration is raised is 1. This is what? A second order reaction, because the power to which the concentration of the reactant is raised is 2. Or I simply say that because the product depends on only 2 types of concentration. This is also a second order reaction because the product you have here depends on only 2 concentration. This is a third order reaction. Why? Because the product depends on 3 different concentration of the reactant, or simply put, the power to which the concentration of the reactants are raised are equal to 3. Okay, this is a zero order because the product does not depend on any concentration. Because if you solve you are going to have a raised to power 0 will give you a, which is equal to k. So there is no, it is independent. The product does not depend on the concentration of any reactant. I hope you understand this theory of the order of reaction. If you try to understand, you have not gotten it well, go through the video again, listen to it again, and you will have a better understanding. Okay, all this stands as reactant product, so anything can actually be here. Let me give you an example. This is an example I've given to you here that came out as a fourth order, okay, from the chemical equation point of view. If you look at this reaction, I plus I to give you I2 iodine, okay. So this one, R will be equal to Ki with respect to this, okay. I hope you can see what I'm writing. Okay, then with respect to this, you have I again. So this is a second order reaction. Why? Because you can have R is equal to Ki square. Okay, so this is a second order reaction because the product I2 depends on the concentration of 2 reactants, and also you can say because the power to which the concentration is raised is 2. Okay, so it's a second order reaction. I hope you understand. You can see a reaction like this: CHCl3 plus Cl2 to give you CCl4 plus HCl. If you are going to write this, you are going to have R is equal to K into the bracket of CHCl3, okay, then Cl2. So this one will come out as a second order reaction from the chemical equation point of view as we write it. I hope you understand what I'm saying, because the power here is 1, the power is 1. When you add them together, it is equal to 2. But meanwhile, please understand that with respect to only CaCl3, it is a first order. With respect to only Cl2, it is a first order. The overall order becomes 2. Look at here. With respect to only A, it's a first order. With respect to only B, it's a second order. When you add the orders of reaction, it will give you 3. I believe on your own you can determine the order of reaction by deducing them from the rate law. Please understand, if you must know the order of reaction, it is not just depending on the coefficient of the reactant, the stoichiometric coefficient of the reactant, okay, in the overall balanced chemical equation, but you must know how to determine the rate law. If the rate law is given to you in a question, you work with the rate law to determine other parameters. But when it is not given to you and you are required to write the rate law from the equation, then you write it the way it has been explained from the law of mass action, as I have previously explained in my past time videos. Okay, and sometimes they will give you table of values where you will be asked to look for the order of reaction, either by calculation or by graphical method. I'm going to be uploading video on how you determine the order of reaction by graphical method. I'll be solving some difficult questions that many students are finding difficult. So this is the end of this video on order of reaction. I want to believe you quite have a good glimpse understanding about what the order of reaction is all about. Now I'm going to drop some questions for you to do on your own, how to determine the order of reaction. Before you write the order of reaction, write the rate law. When you write the rate law, look at the powers to which the concentration is raised, and you bring out the order of reaction. I remain Akpeji Honesty, your chemistry tutor. Please like my video, share my video, subscribe to my YouTube channel, and tell everyone around you, so that the chemistry that looks so difficult for people, it will be made simple in my YouTube channel. Thank you. Take this question and take it as your assignment. This is the exercise for you. Thank you.